Welcome to Lab Life with the Air Force Research Laboratory.
Hi, I'm Michelle.
And I'm Kenneth. Hello, folks. Today we are talking to Leslie Flocken about wind tunnels, international collaboration, and making the workspace safer during the COVID-19 pandemic.
In 3, 2, 1.
Hello, folks, and welcome back to Lab Life. Today we're joined by our guest, Leslie Flocken, who is an aerospace engineer at AFRL and is currently located on the south coast of England. Welcome to the podcast.
Yeah, thanks. Thanks for having me.
So we heard that you had a pretty awesome Christmas here recently, one in the French Alps. What was that like?
Yeah, so my current assignment, as you just mentioned, is in the United Kingdom, and we're located in the south coast of England, which is beautiful in its own right, but my husband wanted a snowy Christmas. So we headed over to Chamonix, France, which is in the Alps. And that region of France is very beautiful, and we had a great time exploring the snowy mountains and the various villages. So while we were actually in Chamonix, we went up to the Aiguille du Midi mountain, which provides views of Mount Blanc, which is the highest point in Europe. So it was really cool. And there's this tourist attraction there called Step into the Void, where you actually are stepping into a glass box, and there's nothing below you for 3,000 feet. So it's really cool attraction, and I don't know, I jumped right in. So that was really neat. It was a fun time to be there. There was a lot of wind, lots of snow. We actually had quite a few days where the lifts were closed just because of the high winds. But that box is the glass box is meant to withstand like 200 miles per hour of wind forces or something like that. So pretty cool engineering feat.
Even on a mountain, I mean, so I've told viewers before, but I've got a bit of a fear of heights, so that is definitely making me tremble a bit. I mean, when I went on like the Willis Tower here in the States, that was enough for me in a glass box. I didn't even go near it. But to hear that, I mean, there's definitely a level of adventure and like bravery there, and the fact that you have a chance to travel to such cool places is phenomenal from where you're based. But going back on something you mentioned, you said it got kind of windy there, a little some gusts that picked up. Funny enough, that kind of ties into what you do for the research lab and what you're doing in the UK. Can you kind of tell us what your work with wind tunnels is about?
Yeah, so I spend a lot of my time not only in wind tunnels, but also doing all the preparation for them. So all the planning, model development, and then on the flip side, doing all the analysis on the data that comes out of wind tunnels. They're really important for aircraft development. We use wind tunnels to simulate flight and collect hundreds of hours of data on an airframe before we actually take it to flight. So basically, wind tunnels serve as a low-cost and low-risk alternative to doing a bunch of flight tests. We can use them to study a lot of different things like the airframe aerodynamics, the propulsion system, the stability of the vehicle, material properties, and on and on. There's really a lot of different things you can do with wind tunnels.
And that's something that we want to make sure we don't blow over here, but we want to take a step back after kind of going to that amazing work you're doing with wind tunnels. So let's start from the beginning. How did you get to this point to be a wind tunnel expert, or at least someone working in them?
I actually started my career with the Air Force when I was still in high school. I applied for the Wright Scholar Program, which is still an active program, by the way. So people can still apply to it today. And it gives students interested in STEM careers, so science, technology, engineering, and math, an opportunity to gain experience into these career fields. Each Wright Scholar receives a mentor in AFRL and works with that mentor throughout the summer. And the program is also closely tied with local universities. And when I participated, we did a host of tours throughout AFRL where you can really get exposure to the different types of career paths you can take within STEM. And that was really important for me. So I knew before applying for the program that engineering was high on my list of career paths, but I didn't know what type of engineering was the best fit for me. So my 2 summers as a Wright Scholar before I started my university studies really helped me decide that I wanted to pursue aerospace engineering. And that ultimately led to spending a lot of time in wind tunnels.
And how cool is that you got the chance to not only view these tunnels, but get tours around the lab to get a really good feel for what you want? It sounds like that the right scholars program here, at least it's more of an exploratory program where it's really saying, hey, let's help find your career path or find a future that you could love to participate in.
Exactly. And that's why, they have all these programs with the local universities where they'll take you to Wright State or the University of Dayton. And that day you'll just focus on, the mechanical engineering side of things and building different linkages and see how those work. Or a different day you'll go into the medical school at Wright State. And if you're interested in the medical field, that's a really great opportunity to see what that's all about. So yeah, a really awesome program that AFRL offers.
Yeah, we've had a lot of team members get their start, in these student programs, and they really end up with some fascinating careers from that early exposure to the laboratory. So what did your journey look like from, being a Wright scholar to your present day job with AFRL?
Yeah, so my first internship with AFRL was actually in the Sensors Directorate. So there I worked with some really smart mathematicians and electrical engineers. And the group I worked with focused on the different ways to use imagery. So during my assignment, for example, I helped set up an experiment where we collected data on individuals walking while carrying different concealed items. So this data was then used to test various tracking algorithms and determine if a person walks differently if they're trying to conceal something. So very cool and really important research. And I enjoyed my time in the Sensors Directorate, but I ultimately determined that research area wasn't really for me. But luckily, again, AFRL was extremely helpful in letting me explore the different opportunities. And I ended up getting a placement with what was then called the Propulsion Directorate. And that's where I got my exposure to aerospace engineering. And I started in the Propulsion Directorate in the High-Speed Systems Division, and that's where I absolutely fell in love with high-speed research, and I knew it was the right fit for me. So
for our listeners, what's that work like? What is a wind tunnel? I hear the Wright brothers used one or made one or something like that. What are you talking about?
They are basically a tool that we use to take air from the outside and compress it into normally a smaller space where you're getting it to the right pressure and the temperature conditions before you flow it over a wind tunnel model. And that really, getting it to those right pressure and temperature conditions is what helps us simulate flight once the air is actually going over the wind tunnel model. That takes quite a bit of energy to do that, but in the end, that's what is so important and what allows us to simulate flight and ultimately save the Air Force money. Because if we were to go and take a concept straight to flight, there's a lot of potential for risk or things to go wrong, and the wind tunnel just really lets us figure out our concepts and mature them before we spend a lot of money on them.
I've had the opportunity to see a few of AFRL's wind tunnels, and maybe some more historical relevance. But when you talk about a model, so you have a scaled down version of a plane, an aircraft, a UAV or something else. You want to see how air flows around, and then you see how it reacts instead of us having to build the whole plane essentially. And I know there's aspects of probably some computer simulation or digital engineering that can do some of this, but this is actually hands-on. You see how the air actually flows over different materials and shapes.
Yeah, so you mentioned computer simulation. So those are a really important aspect of our aircraft development as well. So they kind of, computer simulations and the wind tunnel go hand in hand. And we use our computer simulations to make sure we understand how the vehicle is going to perform in the wind tunnel as well as in flight. And we can kind of use, the wind tunnel to bridge between what we can do on a computer and what the flight experiment is going to look like.
And with that, kind of touching on the model, so do you use similar materials that the model would have, let's say, with the full aircraft, or is there a special way you prepare them for the wind tunnels?
Yeah, so the type of wind tunnel test and the tunnel facility is going to determine not only the type of material you use, but also the size of your model and your instrumentation. So you mentioned material. Material becomes really important when we're talking about engine testing, for example, because a high-speed engine can get to some pretty hot temperatures. So I've actually literally seen metal heat up to the point where it looked like it was red or like fuchsia, really like bright pink, because it was just so hot. And so, in those kind of tests, material is really important, and we want to be testing the material we're going to be using in flight so we can see, how the thermal properties change. Does the, material expand, or does the shape warp the vehicle and ultimately change our vehicle's performance? So yeah, you're absolutely right. Material selection is an important part of wind tunnel testing, especially when we're talking about, propulsion type testing.
That's a fascinating element you touched on, that it sounds like there's more than one type of wind tunnel testing. So that can dictate what models you get and kind of how you prepare for each test.
Yeah, absolutely. Why don't I actually go into some of the different types of wind tunnel tests that I do in the high-speed world? I might help explain all the different ones. So, and keep in mind that this does not cover all, entities of wind tunnel tests. There's so much more than what I'm going to cover here, but these are the ones that I, deal with in my job. So focusing on aero propulsion integration, which is kind of what my specialty is, we normally start with inlet testing, which looks at how the air is shaped by the airframe as it enters the engine of the vehicle. So here we're interested in how hard can we push the inlet from the engine. So basically, how high can we increase the pressure in the engine before disrupting the flow upstream? So that's, kind of where I normally start with my wind tunnel testing. But next, once we're starting to mature the vehicle further, we'll do direct connect testing. And as the name implies, we actually connect the engine directly to the wind tunnel air. So in this type of test, we're only testing the engine and don't include the airframe at all. But we're really focused on tuning the fuel strategy and looking at the overall engine performance. So normally, when a concept is getting further and further matured, we'll look at doing a graduation type test. And this will be normally called a semi-free jet or a free jet test. And now we're looking at putting in some or all of the airframe and then the complete engine into the wind tunnel. And this testing is really important to make sure we're capturing the combined effects, so the combined propulsion and how that's influenced by changes in the airframe when it heats up, different things like that. So that kind of testing is really important for predicting the true performance of the vehicle, and that's normally done soon before we go to flight test.
So that's really cool. So kind of visualizing that, you guys start from literally using the models you mentioned, but some tests can build up to, you said, the engine, then almost the full aircraft itself. So you actually do scale up as the process goes.
Yeah, for sure.
With that in mind, then, I know eventually once you do the right wind testing and the right modeling, you can actually start flying these vehicles out, actually truly testing. But how long does a process like this take, or does that kind of vary aircraft to aircraft?
Yeah, it varies aircraft to aircraft. Let me think of a good example. So if I'm doing, my own research project where I'm looking at a specific niche in aerodynamics, normally I'll take an existing airframe and go through the process of developing a model scheme, building the model, testing it in the facility, and then analyzing data. And for me, a process like that can take anywhere from 3 months to a full year. Now, when we start talking about more, mature concepts that we're actually going to bring to flight, where we're looking at a full vehicle concept. So, for example, we have AFRL's X-51 program. Its first flight was in 2009 or 10, maybe 10. But anyway, with that program, we were doing wind tunnel testing for years before we actually got to the flight test. And I'm talking 10 plus years of different programs leading up to that ultimate flight test.
That's awesome. Yeah, looking it up, it was 2010 when it flew. And you mentioned that you were part of the team that kind of rounded out those tests.
So 2010 was my first summer in the propulsion directorate. So that's kind of part of the reason why I fell in love with this research, because I was actually sitting in the office and we were waiting to get the phone call from the people out at Edwards Air Force Base in California saying, yeah, we had a successful flight test, or no, we didn't. So I wasn't actually involved in the testing for that program. My, organization was, and my colleagues were. But that is ultimately what got me really interested in high-speed research, because it was just a really exciting time to be in the organization.
I mean, that's so cool. Like, I know you said you're very part of that during such an exciting time. Like, can you kind of describe how you felt like watching this happen? I know it helped really inspire you, but was there anything else like working with these teams, like feeling like you were making history, or at least like they were working on it currently?
Oh yeah, absolutely. I mean, the, program manager for the program sat, just down the hall from me. And yeah, I think it was a really big win for AFRL at the time. And the current programs that we're working on, all are kind of derived from that initial success. And we still refer to the data and especially the lessons learned from that program in our current efforts.
That's awesome. That's really, really cool.
Yeah.
And something I want to make sure our viewers have an idea. So we've talked a lot about the air tunnels, kind of, or how we do a lot of these wind tunnel testing, I should say, and kind of the impact they have. You kind of broached what you did before with some analytic work. What do you do specifically with the wind tunnel tests? What is your role?
I guess I can talk you through a typical wind tunnel test. So my role for a test will definitely depend on the program, but my favorite tests are the ones that involve my own research. So, and that's really because I'm involved in every step of the process in that scenario. So for these types of tests, I'll start with the model design and manufacturing. And here I'm really working with model vendors and also the facility team where we're going to be testing, just to ensure that the model is basically, structurally safe to go into the wind tunnel test. And it's not going to go flying down the wind tunnel and destroying millions of dollars of equipment. We want to make sure it's structurally safe and sound. So while we're working on the, model design and manufacturing, at this point, I'll also be laying out my instrumentation strategy, and that determines really what the ultimate data is that we're going to get out of the test. I'll also spend this time developing the test matrix. So here we're looking out, laying out all the different test points that I want to collect during the test. And I'll also normally be collecting previous test data as well as data from our computer simulations that we mentioned earlier that really serve as predictions for how the model's performance is going to be in the wind tunnel. After the model is built, I'll go and inspect the model to make sure it's built to the desired specifications. So this means making sure we have nice, smooth transitions, there's no bumps, there's no steps, because that can really corrupt your tunnel data. And then once it's time for my test slot, I'll normally travel to the facility and then start working with the larger test team to install the model into the tunnel. So moving on to, I guess, what a typical test day would look like for me. Basically, I'm analyzing the data as it comes in. And I'm comparing it back to those predictions we just talked about to make sure that it's performing as expected and that we're on track with the experiment. And if needed, I can make adjustments to the test matrix to ensure that we actually meet the test objectives in the end. So test points will be coming in. I'll be looking at the data. We'll reach a point where we maybe need to do a model change. So that could be as simple as moving the aileron to the control surfaces to a different deflection angle, or it could be as complicated as swapping out a complete different wind tunnel model. So I'll normally be involved in that, and then we'll proceed again with collecting data, analyzing it, and so on.
So that's this is gonna be a weird example, but follow me here. This is pretty cool because it reminds me back in school of being in theater almost. Like you have this almost like this a lot of control over, let's say, this play or this test, and you're able to help like tweak it, make sure it sounds good, get all the people in place, and ensure that everything's executed properly and tested. So once we perform and show this live, everything goes off without a hitch. So I mean that's a lot of work. I mean you really do have you're right. Every aspect of this process you're taking part in.
Mm-hmm. Yeah, absolutely. And that doesn't even mention the amount of time I spend after the test is over analyzing the data, packaging it up into a nice report where we can actually use that data to, you know, fly out simulated trajectories for the vehicle and really look at how we expect it to perform once it gets to like a flight system.
And a lot of these research topics you cover, like testing different aircraft you mentioned, these are usually new airframes that you're tasked with testing, or are some of these ideas that you come up with saying, hey, maybe we can improve an older system. Let's try that out.
It's really a mix of both. Sometimes we'll be working with, you know, the big contractors like Lockheed and Boeing and working with them on kind of a joint concept. Other times it is a like homegrown AFRL idea, like, hey, what if we did this? Will it improve, you know, our performance for the vehicle? So it's really both, all of the above.
I'm just wondering too, we have such a focus on space. I think even this culture now, like, you know, do people or aerospace engineers, are they also testing space vehicles in wind tunnels?
Absolutely. I personally don't, because I'm a big fan of air-breathing engines, and I think that's what's really cool. But absolutely, we definitely have people working on the space regime. I consider them my colleagues at NASA, because I do a lot of testing at NASA. A lot of them do space testing in their wind tunnels. And in fact, a lot of them were involved in the space shuttle wind tunnel testing, which personally I think is just really cool. That actually brings up kind of a funny side point. So NASA is this like iconic, world-known organization. And it's funny because I'm, you know, in the process of helping the UK plan 2 wind tunnel tests at NASA right now. And so I have a lot of experience testing there, so hopefully I'm an asset to the team. But it's what I find really interesting is that I'll be walking down the street here in England and I'll be seeing people wearing NASA t-shirts. And it's just so crazy how, you know, well-known and iconic the organization is that people across the world are wearing NASA gear. So I still get like really excited when I get to work with NASA, you know, on a test, because for a lot of aerospace engineers, that is the dream job, because they want to be in space, dealing with space or next generation aircraft. So I, still get excited working with NASA.
Yeah, I have to say, being on a like sort of a marketing team, we get jealous sometimes because, you know, AFRL's doing cool stuff, but NASA's got the brand recognition. Whether I walk into Target or down the street in London, I'm gonna see some NASA meatballs on shirts. But
exactly, and I think that's one of the things that a lot of young engineers don't realize is, you know, you don't have to actually work for NASA to work with NASA. So like all of the programs I've been involved in, all of the major programs, NASA has had some sort of partnership with AFRL. So the two organizations actually work together really well. But I don't think a lot of people realize that, you know, you can work with NASA and work with them through AFRL.
absolutely, I was able to cover from a communications perspective some of our equipment and testing of a green propellant that went up on a NASA launch in coordination with SpaceX. So it's not just NASA does all this, AFRL does all this, or the Air Force does all this. It's really a collaborative effort. And if we think about the roots of NASA, when they started, a lot of that groundwork was really laid by the Air Force in the research and development that our predecessor labs did. But that's another whole episode with our historian Kevin Resnick. I'm sure he could really get into the roots of this. But in present day, collaboration, it didn't stop. And it's interesting because you're in the UK now, and you're part of the Engineer and Scientist Exchange Program, working with the Defense Science and Technology Laboratory. And they're even coming to the United States to use wind tunnel testing facilities. I know AFRL has various types, whether it's a vertical wind tunnel or shaped different, all over the country. You have some at Arnold Air Force Base, some at Wright Pat. I'm sure they're all over the place. That's because these, my understanding is these are just really expensive facilities and one of a kind in the world. Really, you get something out of each different setup.
Absolutely true. And AFRL has a lot of one-of-a-kind facilities. Like the vertical wind tunnel you mentioned, I'm pretty sure that's the only one that exists in the Western world, at least. And the facilities at Arnold AEDC, I mean, that center was built for wind tunnel testing, which I think is really cool because, you know, a lot of the facilities that we test in, right, they take a lot of power to bring that air to the right conditions, the right pressure, the right temperature. When you're testing at AEDC down in Tennessee, because that area was built for wind tunnel testing, they don't have to compromise too much on power. They're really only compromising or sharing power with other facilities on the same center. But when we're talking about testing at some place like Wright-Patterson, you know, a lot of our tests, for example, in our research labs in the Aerospace Systems Directorate, we test in the evenings overnight because not only is the power cheaper overnight, but we're also not competing with the you know, all the people who have their computers turned on, their lights turned on, the HVAC systems that are running during the day. So we actually run at night to take advantage of that power drop when everyone else has left the base. So it's kind of neat the way that, you know, we make wind tunnels work. I just think it's pretty cool.
Definitely sounds like it. I imagine there's a whole job probably dedicated to monitoring that availability and things like that. So if we go back to the thread of one of the reasons we're really interested in talking to you is the fact that we don't have a lot of AFRL folks that work in different parts of the country. We definitely do through our Air Force Office of Scientific Research, but you're actually normally assigned to Wright-Patterson Air Force Base in our Aerospace Systems Directorate. You know, what is this exchange program about, and how did you get involved in it?
Yeah, so I guess before diving into the program, I'll take a step back and maybe talk about myself a little bit more. So I grew up outside Wright-Patterson Air Force Base. That's home for me. My parents were employed as Air Force civil servants, so I like to say I joined the family business. But both my parents actually spent their careers working with our foreign partners. So our social events for me growing up typically included the foreign liaison officers from, and their families really, from Belgium, the Netherlands, Australia, Denmark, so on. And this really instilled an appreciation for other cultures and really also a passion for travel. But for my career as an engineer, the Engineer and Scientist Exchange Program, or ESEP, was the perfect way for me to get that same cross-cultural exposure that I so admired from my parents' careers with the Air Force. So I learned about ESEP shortly after I joined AFRL and decided to apply for the program a few years after finishing my master's degree. I mean, ESEP is just truly an amazing program. I just couldn't turn down the opportunity to, you know, move to a different country and immerse myself in a new culture and see how another country does defense research. I just can't pass that up. So I just started my second year at DSTL, the Defense Science Technology Laboratory in the UK.
That's awesome. And getting the chance to work here then and having this cross-cultural perspective that you've really grown up with, how has this like a particular scenario kind of changed you or helped you grow professionally?
Yeah, so ESEP has been a great, you know, development opportunity, both for my personal and my professional growth. Personal because I have gotten to immerse myself in another culture and really grow from that experience. Professional because I've gotten to really focus on building out my technical depth, which I think is really important for my future. A lot of times, you know, people get tasked with, let's say, other duties than assigned, you know, that we all get bogged down with. And here, because I'm slightly removed from the organization, I've just gotten to focus on the technical side of things, which has been really great for me. I also see a great benefit in getting exposure to the way another country does defense research and learning what works and what doesn't. And I would say finally, I've also made connections with some really great engineers in the UK government, industry, and academia that I know is going to be important for future research partnerships.
Absolutely. And is this team then, how many people are taking part of the ESIP program beside you? Or are there other international partners at DSTL?
I think my year when I was selected for ESEP, there were a total of 9 scientists and engineers selected throughout the whole Air Force. And it's civilians and military. And I think that year we went to 8 different countries. So I think there's 2 of us here in the UK from that year. And we have other folks in Italy, France, Spain, Australia, trying to think of where else. But I think there's about 16 different countries that we have agreements with under the ESEP program where you can do exchanges like what I'm doing. So while I've been here in the UK at DSTL, there has been, I think, 3 other ESEPs at the same time where we've overlapped. And yeah, we actually all do different research. So I'm the only one that does the high-speed research. We have another person working on the space side of things, and then another person working more on, laser stuff, stuff outside of my area of expertise for sure. But yeah, it's really cool. And DSTL is also really interested in sending people from the UK over to AFRL. So just this past year, there was a young engineer who came from DSTL and spent 6 months working in the Aerospace Systems Directorate. So we're, DSTL and AFRL both are really trying to increase the collaboration between the 2 organizations. So it's really cool and, really exciting times, I think.
Yeah, we'll have to try to talk to him sometime, get him on the podcast to see what his perspective was to, is experiencing working with some of our colleagues at Wright-Patterson Air Force Base. And speaking of unique experiences, though, you were in the news earlier this summer. You participated in a virtual COVID-19 hackathon. What was that about?
We all kind of went into a lockdown, right? The US started, working from home exclusively back in March, I think, and the UK followed suit shortly after. And as a way to, I guess, get people working in this new paradigm where we're all working from home and not really seeing each other on a regular basis, DSTL launched this, they called it a hackathon. And basically this one was focused on how can we get people back to work safely? And, I don't even know if I, had always intended on participating in the hackathon when it was first released, but I saw some of the initial ideas for the first week of the hackathon where people were brainstorming different ways to get people back into the office safely. And it just happened that one of the concepts someone had posted, I thought I could basically help with. It was kind of a similar work to what I had done previously when I was doing my graduate degree at Georgia Tech. So when I was at Georgia Tech, I did a project where we looked at how people get on and off an aircraft and the different interactions that happen during that process of getting your bag, not bumping into people as you're getting off the airplane. And basically, I took that modeling approach and applied it to people working in an office environment where you can have people, essentially get a higher risk of transmitting COVID once you come in close contact with each other. So basically, I simulated a workspace and watched people, work throughout a 48-hour work week where they're sitting at their desk, they're going to meetings, they're going to take a break in the kitchen area, and basically looking at, how can we make changes into the office environment. So, the desks, like how they're laid out or how many people are in the office. So what kind of changes can we make to reduce the risk of COVID transmission in the workspace?
And how great is that? The fact that work you did beforehand actually had an impact now. So you're able to pull back an old research you'd done like that. That's wild. And after doing this, have you seen a lot of these practices or ideas that you have found implemented in your office, or at least seen people start to adopt these?
Answering the kind of the first part of your point, that it was really cool to pick up something that I had done back in grad school. Education, I think, is really important. And I guess I'll mention this here too. That was one of the things that I just think is great about the Air Force. Not only did I work as a co-op student while I was doing my undergraduate studies, with AFRL, But the Air Force also paid for my graduate education as well at Georgia Tech. So I was in the Palace Acquire program, which is a 3-year training program where one of those years is dedicated to getting your graduate degree. And so I moved down to Atlanta, Georgia, and did my degree in aerospace engineering and learned a lot from that program and got to work on a lot of really cool programs. Saw aerospace and the FAA, and got to not only work on the projects but also lead them, so build up my management skills as well. So anyway, that's answered the first part of your point. The second part, have I seen it, the COVID modeling implemented? So the initial hackathon, we actually only had, I think, 4 days to take the idea and mature it into a concept. And that's where we won that first place award for this hackathon. And because we did really well, they actually took the concept and gave us some additional funding and a 2-week time period to mature it further. So we basically matured it to a conceptual design and submitted that to the UK's, I gotta get this right, Rapid Assistance in Modeling the Pandemic Committee, RAMP, and they did a peer review of the work and provided some really good feedback. So now that project is basically sitting as a package for someone to pick up and develop and hopefully take it to the point where it can be used by the wider world. So anyway, but besides that, so seeing the COVID modeling itself, I think we did really get some good data out of it. For example, one of the things that I've seen implemented is that if you have a row of desks, the people that sit on the desk closest to the aisle walkways are going to be the highest risk for getting the disease. And I know where I work here at DSTL, those aisle desks are all blocked off. So people can't sit there because, of that increased risk. So I do think that, a lot of organizations are doing some really smart, implementations or risk mitigation strategies to helping, keep people safe as we're returning to work.
That's great. And this whole, response to the pandemic has been, we're relying on our scientists and engineers and smart people to keep us safer or come up with medical solutions. But in the interim, it's just really cool that you could pull on that research you did as a graduate student and then apply it to a new problem set that you probably never imagined would come up in our lifetimes, really. So
that's true. And I also got to work with some folks at DSTL that I wouldn't have worked with otherwise. So some people who deal with like chem and biological warfare, like I never would have interacted on that person or with that person, in my normal role as a aerodynamicist. But because I, took my aerospace engineering knowledge and applied it in a different manner, I was able to interact with some different people and collaborate with a lot more people than I would have normally across the DSTL organization. So it was a really, really good opportunity in the end.
And it really seems like so much of your career is focused around this collaboration, whether it's NASA or the UK or other partners in the Air Force. It's really cool. And thanks for joining us today. We've learned a lot about wind tunnels that I wasn't aware of, and really this really cool exchange program that is an opportunity for our scientists and engineers.
Yeah, absolutely.
Make sure to follow us on social media at Facebook, Twitter, LinkedIn, Instagram, and YouTube at AF Research Lab. And remember, stay curious.
Logging off.